blown head gaskets, chronic oil consumption, catastrophic failures. Some truck engines earn their bad reputations the hard way. From flawed designs to manufacturing shortcuts, some engines became case studies in what can go wrong when reliability takes a back seat. When you go out to buy a used pickup or commit to a workhorse for the long haul, avoid these truck engines. Let's get started. Number 10, Mercedes-Benz MBE 4000. Introduced to the North American market in 2002 through Daimler Trucks North America, a Mercedes-Benz MBE 4000, a 12.8-liter inline-six diesel engine, was designed as a medium and heavy-duty option for Freightliner and Sterling Class 8 tractors. Built in Mannheim, Germany, and adapted for U.S. emission standards, it earned early praise for smooth power delivery, up to 450 horsepower, 1,550 foot-pounds of torque. But problems soon surfaced. Fleet maintenance logs from carriers in the Midwest and Ontario documented recurring injector failures, clogged EGR valves, and erratic electronic sensors before 300,000 miles. Wiring harness corrosion and ECU pin faults compounded downtime, and turbocharger replacements frequently ran $3,000 to $8,000. Complete overhaul surpassed $20,000 due to expensive German-source parts. But wait, it gets a whole lot worse as we move down the list. Number 9, Detroit Diesel Series 60. Introduced in 1987 and once celebrated for million-mile durability, Detroit Diesel's Series 60 faced a troubled chapter during the U.S. Environmental Protection Agency's 2002 emissions mandate. To meet the new standards, Daimler Chrysler's Detroit Diesel division added an exhaust gas recirculation EGR system to the 12.7 and 14-liter inline-six engines used in Freightliner, Western Star, and Volvo tractors. Built primarily at the company's Redford, Michigan plant, the 2002 to 2007 EGR-era engines developed chronic soot buildup that clogged EGR coolers and led to overheating, blown head gaskets, and cracked cylinder heads, particularly in hot southern states and under heavy haul conditions. Fleet records from major carriers such as Schneider National documented major repairs well before the traditional 500,000-mile benchmark. Owners reported repeated sensor and ECM faults that triggered limp mode events. Routine EGR or diesel particulate filter DPF cleanings cost about $2,000 to $6,000. Headwork or full end frame rebuilds often exceeded $20,000. Now, number 8, GM 6.5-liter turbo diesel. Produced from 1992 through 2000 at GM's Moraine, Ohio engine plant, General Motors 6.5-liter turbo diesel V8 was intended to power heavy-duty pickups and suburban Yukon SUVs as a successor to the naturally aspirated 6.2-liter. Rated up to 215 horsepower, 440 foot-pounds of torque, it was offered in Chevrolet and GMC 2500 and 3500 trucks, as well as Hummer H1s. Despite respectable early sales, the electronically controlled Stanadyne DS4 injection pump proved a chronic weak point. Its pump-mounted driver PMD module sat directly on the hot pump body, leading to overheating and sudden engine stalling, often before 150,000 miles in towing service. Many owners also reported cracked cylinder heads or main bearing webs when gross combined weights pushed the design beyond its limits. Injection pump or PMD replacements typically cost $1,200 to $2,500. Full short block rebuilds, on the other hand, frequently top $4,000 up to $8,000. Moving on, number 7, International VT365. Produced from 2003 to 2007 at Navistar's Indianapolis engine plant, International's VT365 diesel was the medium-duty counterpart to Ford's problematic 6.0-liter Power Stroke, displacing 365 cubic inches or 6.0 liters and rated up to 230 horsepower with 620 foot-pounds of torque. It powered international 4000 series trucks, IC school buses, and various municipal fleets. However, it quickly developed a reputation for chronic reliability issues. Fleet operators across the United States and Canada reported blown head gaskets, warped cylinder heads, clogged EGR coolers, and failing high-pressure oil pumps or injectors. These issues often appeared well before 200,000 miles and stop-and-go delivery or bus service. Repair bills were steep. Head gaskets or full head replacements typically ran between $4,000 to $10,000. Injector or oil pump repairs added $1,000 to $4,000 each time. Wait though, there's more from where that came from. Number 6, Ford 6.4-liter Power Stroke. Built for the 2008 to 2010 Super Duty line at Ford's Kentucky truck plant and designed by Navistar in Indianapolis, Ford's 6.4-liter Power Stroke diesel was intended to meet new U.S. EPA emission rules with dual sequential turbos and a diesel particulate filter. Rated at 350 horsepower and 650 foot-pounds of torque, it quickly became notorious for costly failures. Owners across the United States and Canada reported raw diesel fuel leaking past injector seals and diluting engine oil, which accelerated wear. Pistons cracked, sometimes before 120,000 miles. High-pressure CP3 fuel pumps and the variable geometry turbochargers were also common failure points, while EGR coolers and DPFs clogged under heavy towing. Many trucks required major work between 100,000 and 200,000 miles. Bulletproofing packages, which included upgraded fuel pumps, stronger pistons, and cooling system overhauls, ran $8,000 up to $15,000. Complete crate engine replacements could cost $10,000 up to $20,000. Many owners resorted to emission deletes despite legal risks. Number 5, Ford 6.0-liter Power Stroke. Installed in 2003 to 2007, Ford Super Duty pickups and E-Series vans, Ford 6.0-liter Power Stroke diesel was designed to meet tighter U.S. emission standards with an exhaust gas recirculation, EGR system, and high-pressure oil injection. 325 horsepower, 560 foot-pounds of torque, but it suffered chronic failures soon after launch. Warranty records and court filings show tens of thousands of claims for blown head gaskets, ruptured EGR coolers, and injector or high-pressure oil pump breakdowns, often before 100,000 miles. Ford's inadequate torque to yield head bolts allowed cylinder pressures to lift the heads under heavy towing, mixing oil and coolant and causing overheating. Dealers frequently replaced EGR coolers, head gaskets, and injectors, but repeat failures were common. Owners spent $4,000 up to $8,000 on bulletproofing packages with ARP head studs, upgraded oil coolers, and EGR deletes. Complete engine replacements range from $10,000 up to $15,000. Number 4, Caterpillar C13 A-Cert. Produced between 2004 and 2010 at the company's East Peoria, Illinois plant, Caterpillar's C13 A-Cert was introduced as a 12.5-liter on-highway engine designed to meet stringent EPA 2004 emission standards. Unlike earlier mechanically simpler C13 units, the A-Cert version employed advanced electronic controls, multiple actuators, and variable valve timing to manage exhaust gas recirculation and optimize combustion. While it delivered up to 470 horsepower and 1,650 foot-pounds of torque, the complexity brought chronic issues: overheating, cracked cylinder heads, turbo failures, excessive oil consumption. In-frame overhauls became necessary well before 500,000 miles. Repair costs were substantial. Header turbo replacements ran $10,000 to $20,000. Full overhauls could exceed $30,000. Moving on. Number 3, the Cummins ISX. The Cummins ISX, specifically the early EGR DPF generation, produced between 2007 and 2010, was designed to meet EPA 2007 emission standards for Class 8 trucks. Used widely in Freightliner Cascadia, Peterbilt 387 and 386, Kenworth T660, and International ProStar models, the ISX incorporated exhaust gas recirculation, EGR, and diesel particulate filter DPF technology to reduce nitrous oxide emissions. While offering up to 600 horsepower and 2,050 foot-pounds of torque, the engines were prone to repeated DPF clogging, failed regenerations, sensor faults, and sudden limp mode events, often under 200,000 miles, sometimes escalating to drop liners or cam and cylinder damage due to coolant intrusion and lubrication deficiencies. Maintenance costs were steep. Routine DPF cleaning or replacement ranged from $2,000 to $6,000. Catastrophic engine overhauls exceeded $20,000. Many operators eventually converted to selective catalytic reduction SCR systems. The later ISX 15 models also significantly improved reliability. Number 2, the Caterpillar C15 A-Cert. Produced from 2003 to 2010 at Caterpillar's engine facilities in Mossville, Illinois and Victoria, Texas, Caterpillar C15 A-Cert was intended as a high-performance EPA-compliant Class 8 on-highway diesel engine. Found in Freightliner, International, Kenworth, and Peterbilt tractors, the C15 A-Cert featured a twin-turbo setup in the A-Cert emission system, which employed advanced fuel injection timing and electronic controls to meet 2004 to 2007 EPA standards. While rated up to 600 horsepower and 2,050 foot-pounds of torque, the engine became notorious for high operating temperatures, cracked cylinder heads, excessive oil consumption, and frequent in-frame overhauls. Many fleets reported these issues well before the expected heavy-duty service interval of 500,000 to 700,000 miles. Repair costs for in-frame work range from $15,000 to $25,000. Full engine replacements often exceeded $30,000. If you thought this was bad, take a look at this next one. Number 1, Navistar Max Force 13. Produced between 2008 and 2015 at Navistar's Melrose Park, Illinois, and Springfield, Ohio facilities, the Navistar Max Force 13 was intended as a flagship heavy-duty diesel for international trucks, targeting EPA 2010 emissions compliance using an EGR-only strategy without selective catalytic reduction (SCR) or diesel exhaust fluid (DEF). 410 to 500 horsepower, up to 1,850 foot-pounds of torque, but the engine had serious flaws: extreme soot accumulation, clogged coolers and oil coolers, blown head gaskets, overheating that resulted in short engine life. Repeated downtime and premature removals were often necessary under 300,000 miles. Maintenance and in-frame repairs could reach $15,000 to $40,000 over a truck's life, while large fleets reported six-figure annual losses due to downtime and unscheduled repairs. Well, what are your thoughts on the whole thing? Let us know in the comments below. Love trucks and want to learn more? We upload regularly. Subscribe to get on board.